if x is a binomial distribution of n comma p and y is n minus x, then y is what? So first, x is given as binomial distribution of n comma p and y is n minus x. So here x is defined as number of successes in n trials. So now y is n minus x. So therefore we can say y is number of failures in n trials, since this is what is remaining out of number of successes from the total number of trials. So y is total number of failures in n trials. So for this the probability is p. So therefore the probability will be q, which will be 1 minus p. So therefore we can say y is a binomial distribution of n comma q, where q is 1 minus p, since it is a probability, this is number of failures. So this can be written as b of n comma 1 minus p, where q is n 1 minus p. So the answer is b, n comma 1 minus p. A binomial probability distribution is symmetrical if the probability p of success in a single trial is. So definition of symmetrical distribution is p is equal to q. Probability of success is equal to probability of failure. So when p equals q, we know that p plus q is equals 1. Sum of all the probabilities is 1. So b equals q. So therefore p plus p is equal to 1. So therefore p will be 2p will be 1. Therefore p will be half. So the answer is equal to half b. So when p equals half, the distribution will be symmetric. The probability that a marksman will hit a target is 1 by 5. So p is 1 by 5. The probability that at least one hit in 10, probability of that it will hit at least one time in 10 shots is, so n is 10. We have to find p of x greater than equal to 1, since we are asked p of x at least 1. So this is the same as 1. So we use 1 minus none rule, that is p of x greater than equal to 1 is p of total probability minus p of 0. So p is 1 by 5. So therefore q will be 1 minus p, which is 4 by 5. So this is 1 minus p of 0. P of 0 is nc0, that is 10c0. P raised to 0, that is 1 by 5 raised to 0 into q raised to 10 minus 0. So this will be 1 minus, this is 1 into 4 by 5 raised to 10. This will be 1 minus 4 by 5 raised to 10, which is option C. If 5 coins are tossed simultaneously, then probability of at least one head is, so 5 coins are tossed, so n will be 5. So we assume the coin is fair, so probability will be p will be half and q will be half. So what we are supposed to find is probability of at least one head. So this will be p of x greater than equal to 1, which is the same as 1 minus p of x equals 0. So this will be 1 minus p of x equals 0 is 5c0, p raised to 0, q raised to 5 minus 0. So this will be 1 minus 5c0 is 1, p raised to 0 is 1 into q raised to 5, that is half raised to 5. So this will be 1 minus 1 by 32, which is equal to 31 by 32, which is option B. An experiment succeeds twice as often as it fails, then probability that in next six trials there are at least 4 successes. So we are given that probability of success is twice as failure. So p is 2 times q. So therefore, q is 1 minus p. So we can say p equals 2 into 1 minus p. So this will be p equals 2 minus 2p. So 3p will be 2. So therefore p equals 2 by 3. So therefore q equals 1 by 3, since it is 1 minus p. So p is 2 by 3, q is 1 by 3. So first we'll find the general probability. P of x equals r is 6cr, 2 by 3 raised to r, 1 by 3 raised to 6 minus r, which is equal to 1 by 3 raised to 6 into 6cr into 2 raised to r. So probability that there are at least 4 successes, this is equal to x is equal greater than 4, which is equal to p of 4 plus p of 5 plus p of 6. So p of, we take 1 by 3 raised to 6 common, so 1 by 3 raised to 6 raised to 1 by 3 raised to 6 into for these are the values of r, that is 4, 5 and 6 respectively. So we substitute the value, so this will be 6c4 2 raised to 4 plus 6c5 2 raised to 5 plus 6c6 2 raised to 6. So simplifying this, we'll be getting 2 raised to 4 by 3 raised to 6 into 15 plus 6 into 2 plus 4. We took 2 raised to 4 common from these terms. Further simplifying this, we'll be getting 16 into 31 by 729. This is equal to 496 by 729, which is option A. India plays 2 matches each with West Indies and Australia. In any match, probabilities of India getting 0, 1 and 2 points are 0.45, 0.05 and 0.50 respectively. If the outcomes are independent, then the probability of India getting at least 7 points is, so India is supposed to get 7 points. So only possible ways are, there are 4 matches played total, 2 with West Indies and 2 with Australia. So total number of matches will be 4. So n will be 4. So total number of matches is 4. So there are 4 matches. So India can gain at least 7 points by either getting 2 in all matches, or another option is getting 2 in 3 matches and 1 in the last match, or any one match. So 3 times 2 or 1 or 2 in all matches. So there are two possibilities. So first will be probability. So total probability will be probability of getting 7 points. Here will be getting 7 and here will be getting 8. So at least we want probability of at least 7. So this will be the total of probability of 7 points plus probability of 8 points. So this will be probability of for 7 points is 4c3. Now probability for getting 1 point is 0.05 and probability of getting 2 points is probability of getting 2 points is 0.5. So we substitute accordingly. So either we can India can get 2 points thrice, that is 0.5, that is the probability of 2 points, thrice, that is cube, and 1 point for once, that is 0.05, or 2 for all the games, that is 4c4 0.5 raised to 4. So solving this, we'll be getting 0.5 cube into 0.2 plus 0.5, that is equal to 7 by 80, which is option B. Probability of India winning a test match against England is 2 by 3. So P is 2 by 3. So probability of losing is Q, which is equal to 1 by 3. So assuming independence from match to match, probability that in a 7-match series, India's third win against in a 7-match series, India's third win occurs at 5th is. So probability, what we have to find is there are 7 matches and India is supposed to win its third win. India is supposed to win the third time in the 5th match. So 1, 2, 3, 4, 5. So third win should be at the 5th match. So first or second win can be in any order, but it should occur in the first 4 matches. So first we'll be finding the probability that India will be winning the first 2 matches in the first 4 matches, and the remaining probability will be winning a match in the fifth match. So probability that India will win a match in the fifth match is P of let's say last match, which is equal to 2 by 3, which is the same as probability of winning one match. And probability of winning two matches is out of 4 is 4C2 P raised to 2, that is winning 2 times and losing n minus 2 times, that is 1 by 3 raised to 4 minus 2 times, that is 2. So this will be the product will be 8 by 27. So the probability what we want is 2 by 3 into 8 by 27. We multiplied since this sequence will be occurring simultaneously. So this will be 16 by 81, which is option C. A die is thrown 100 times. If success is getting an even number, then variance of the number of successes. So probability of getting an even number is, so there are 6 faces in a die. So there are 3 even. So probability of getting an even number from a die is P is 3 by 6, which is equal to half. So probability of not getting an even number is also half. So number of trials is 100. Variance is given by NPQ. So this will be 100 into P into Q. So this will be 100 by 4, which is equal to 25. So variance is 25, option B. If turning up of 1 or 3 is considered a success for a die, then standard deviation of success in 8 throws is, so n is 8, number of throws is 8, and success is considered when 1 or 3 shows up in a die. So probability of success is, so 2 numbers are considered success out of 6 faces. So this will be 2 by 6, which will be 1 by 3. Therefore Q will be 1 minus P, which is equal to 2 by 3. So n is 8, P is 1 by 3 and Q is 2 by 3. So standard deviation is given by root of variance, and variance is given by NPQ. So this will be root of NPQ, which is root of 8 into 1 by 3 into 2 by 3. That is equal to root of 16 by 9. This is equal to 4 by 3. So the answer is C, 4 by 3. A die is tossed 5 times. If getting an odd number is considered a success, then variance of distribution of the successes. Now a die is thrown 5 times, so n is 5. Probability of getting an odd number is half, that is 3 by 6. So let this be P, probability. So this will be 3 by 6, that is half. So natural Q will also be half. We have to find the variance. So variance will be NPQ. So variance is N into P into Q. This is equal to 5 into half, which is equal to 5 by 4, which is option D. In a box of 100 bulbs, 10 are defective. Then the probability that in a sample of 5 none is defective is, so probability of a bulb being defective is 10 by 100, which is equal to 0.1, or that is 1 by 10. So probability that a bulb is not defective is 1 minus P, which is equal to 1 minus 10, which is equal to 9 by 10. So there are 5 samples and none should be defective. That is, probability for each one of them should be Q. So this will be Q into Q into Q into Q into Q. That is 5 times. None of the bulbs should be defective in a sample of 5. So this will be equal to Q raised to 5, and this is equal to 9 by 10 raised to 5, which is option D. In a binomial distribution, n equals 4 and p of x equals 0 is 16 by 81. Then p of x equals 4 is, so now we are given that n is 4, p of x equals 0 is 16 by 81. But p of x equals 0 is given by n is 4, so 4c0, p raised to 0, q raised to 4 minus 0. This is equal to 16 by 81. So 4c0 is 1, p of 0, p raised to 0 is also 1. So we are left with q raised to 4 is 16 by 81. Therefore, q is equal to 2 by 3 since there are 4 roots. So q is 2 by 3, therefore p will be 1 by 3. So we have E, we have Q. So P of x equals 4 will be 4C 4 1 by 3 raised to 4 2 by 3 raised to 4 minus 0. This is equal to 4C4 is 1 1 by 3 raised to 4 is 1 by 81. So this is 1 into 1 by 81, which is equal to 1 by 81, which is B option. A fair coin is tossed repeatedly. If first 4 tosses show the same result, then probability that fifth toss will show a different outcome is. So there are two possibilities. There are 5 tosses and first 4 are supposed to be same and last 4 are fifth one is supposed to be different. So there are two possibilities. Either it can be heads, 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 heads and tails, or tails, 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 tails and heads. So there are two possibilities. So probability, total probability is the sum of both of these probabilities. So it will be P of H, 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 T plus P of T, 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 H. That is equal to P of H into P of H into P of H into P of H into P of T plus P of H, P of T into P of T into P of T into P of T into P of H. Now P of H is half and P of T is also half since it is a fair coin. So this will be half into half into half into half into half plus half into half into half into half into half. That is equal to half raised to 5 plus half raised to 5. That is equal to 2 into half raised to 5. Now half raised to 5 is 1 by 32. So this is 2 by 32, which is equal to 1 by 16. So the answer is D, 1 by 16. A coin is tossed 2n times. Probability that the number of heads is not equal to number of tails is. So let this be number of trials. So number of trials is 2n. So probability that heads is number of heads is not equal to tails. We can say this as using the 1 minus none rule. Probability that number of heads is not equal to number of tails is equal to 1 minus, that is total probability, minus probability that number of heads is equal to number of tails. So probability that number of heads is equal to number of tails is, we can write this as 1 minus P of n heads and n tails. Since the number of trials is 2n, so that if the number of heads is equal to number of tails, so they will be divided as n heads and n tails. We can write this simply as P probability of n heads. Tails is not necessary since we are considering only the success. So probability of getting a head is P, which is equal to half. Similarly, Q is half. That is probability of failure. Here we consider success to be getting a head. So this will be 1 minus P of getting n heads. So we apply the formula. So this will be 1 minus NCR, that is 2NC. Here R is n. So 2NCN. P raised to R, that is n. Q, which is also half, raised to n minus R, that is 2n minus n. So this will be 1 minus 2NCN multiplying this, we'll be getting 1 by 4 raised to n, which is option C. Two cards are drawn successively with replacement from a well-shuffled deck of 52 cards. Then the mean of number of aces is, so there are 52 cards, so n will be 52. Two cards, there's a mistake, two cards are drawn, so number of trials will be 52. And we are supposed to find the mean of number of aces. So number of aces in a pack of 52 cards is 13. So there are 13 aces in a pack of 52. So probability of getting an ace is P, which is equal to 13 by 52, which is equal to 1 by 4. So there is a 1 by 4 chance of getting an ace. So probability of not getting an ace is 1 minus P, which is equal to 1 minus 1 by 4, which is equal to 3 by 4. So mean of number of aces is mean, which is also given as E of x, is equal to n into P. So this is, now n is 2 and P is 1 by 4. So this will be half. So mean of number of aces is, there's a correction, 13 by 52 is, this is, there's a silly correction. There are only 4 aces, that is 1. So it will be 4 by 52 and not 13 by 52. So there are 15 aces, 4 aces. So P will be 1 by 13. So therefore this will be 12 by 13. So this is 2 into 1 by 13, which is equal to 2 by 13. So the answer is C, 2 by 13. Again, the correction was number of aces is 4. There are 4 aces. Sum of mean and variance of a binomial distribution is 15. If the sum of squares is 117, then the mean of the distribution is, so we are given that mean and variance, sum of a mean and variance is 15. So mean is given by NP and variance is given by NPQ. We are given that mean and variance, the sum is 15. So NP plus NPQ is equal to 15. Second condition is sum of squares is 117. So NP the whole square plus NPQ the whole square is equal to 117. So now we square and divide these terms. So we square this and we square this. So we'll get NP n square p square plus n square p square q square is equal to 117 divided by NP plus NPQ the whole square divided by 15 square. So now we take NP common, and when it is out of the bracket, we'll be getting n square p square. Again in the numerator, we'll be taking out n square p square common. So this will be n square p square 1 plus q square divided by n square p square into 1 plus q the whole square. This will be equal to 117 divided by 225. So n square p square will get cancelled. We are left with 1 plus q square upon 1 plus q the whole square equals 117 by 225. Shuffling the terms, we'll be getting this quadratic equation in terms of q, which is 6q square minus 13q plus 6 equals 0. From this, we'll get q equals 2 by 3. Therefore, p will be 1 minus q, which is 1 by 3. So the mean will be n into p. So for that, we'll be needing P. So we'll using the first condition, that is NP plus NPQ is equal to 15. So we know P and Q. Now we need to find N. So this will be NP plus MPQ equals 15. P was 1 by 3. Q was 2 by 3. So n, taking n common, 1 by 3 plus 1 by 3 into 2 by 3 is equal to 15. Solving this, we will be getting n equals 27. So therefore, what we had to find was mean. So mean will be NP, which is equal to 27 into P is 1 by 3. So this will be 9. So mean will be 9, which is option B. The following table represents probability distribution for a random variable x, and the table is given as 1 2 3 4 5 6 1 2 6, and various value of k is given for each x. So the value of x is what? So we can say summation of p is equal to 1. Probability of all the sum of all the probability for all the values of x is 1. So this can be written as 0.1 plus 2k plus k plus 0.2 plus 3k plus 0.1 is equal to 1. Taking k terms on one side and numbers on the other side, we can write 6k is equal to 1 minus 0.4, which is equal to 0.6. So therefore k will be 0.6 upon 6, which is equal to 0.1, which is option A. A random variable x is defined by 3 with probability 1 by 3, 4 with probability 1 by 4, and 12 with probability 5 by 12. Then E of x is what? So E of x is given as summation of product of p and x. So this will be 3 into 1 by 3 plus 4 into 1 by 4 plus 12 into 5 by 12. So this will be 1 plus 5. This is equal to 7. So the answer is B, 7. A random variable x is specified by the following distribution law. For x equals 2, probability is 0.3. For x equals 3, probability is 0.4. And for x equals 4, probability is 0.3. Then the variance of this distribution table is, so variance is given by E of x square minus E of x the whole square, where E of x is mean or expectation. So E of x is summation of p and x, product of summation of product of p and x. So this will be 2 into 0.3 plus 3 into 0.4 plus 4 into 0.3, which is equal to 0.6 plus 1.2 plus 1.2, which is equal to 3. So E of x is 3. Now E of x square. Now E of x square is summation p into x square, product of x square and p, and summation of that. So this will be 2 square into 0.3 plus 3 square into 0.4 plus 4 square into 0.3. So this will be, sum will be 9.6. So variance will be E of x square, that is 9.6, minus E of x the whole square, that is 3 square. So this is equal to 9.6 minus 3 square is 9. So 9.6 minus 9. So this will be equal to 0.6, which is option A. The probability distribution of random variable x is given below. For x equals 1, probability is 1 by 4. For x equals 2, probability of is 1 by 8. And for x equals 3, probability is 5 by 8. Then its mean is, so mean is given by E of x, which is equal to summation of p into x. So this is equal to 1 into 1 by 4 plus 2 into 1 by 8 plus 3 into 5 by 4. 5 by 8, sorry. So this will be 19 by 8, which is option A. Let x be a random variable which assumes values x1, x2, x3, x4 such that 2 times p of x equals x1 is equal to 3 times p of x equals x2 equals 3 p of x equals x3 equals 5 times p of x equals x4. Then the probability distribution x is, so these are the options given, and these are all the probabilities for respective values of x. So an alternative approach to this solution is we'll use elimination method, that is we'll check the options, and the options are such that we have given all the possible probabilities of the values of x, all the probabilities. So we'll check if the sum adds up to 1, that is we'll check this condition summation of p equals 1. So we'll select only those options which have satisfied this condition. So let's start with D. So the denominator is 31, so numerator should add up to 31. So this will be 10 plus 15 plus 5 plus 2. So this is not 31. This adds up to around 32. So this option is eliminated. Let's check option C. So denominator is 14. So let's check the numerator. This will be 7 plus 4 plus 3 plus 1. So this is again 15, sorry. This adds up to 15, but the denominator is 14. So this option is again eliminated. Let's check option B. So this is denominator is 16. So let's add the numerator 5 plus 4 plus 2 plus 6. And this adds up to 17 and doesn't match with denominator. So this option is also eliminated. So the only option which is left is option A. Let's check this for confirmation. So this will be denominator 61. So numerator will be 15 plus 10 plus 30 plus 6, which is 40 plus 21. 40 plus 21, which is 61. So the numerator is equal to denominator. So the sum adds up to be 1. Sum of all these is 1. So the answer is option A. A coin is tossed twice and x is the number of tails. Then E of x is what? E of x is nothing but mean. So we are given that coin is tossed twice. So n is 2. That is number of trials is 2 for a binomial distribution. Number of trials is 2. And probability of getting a tail is 1 by 2, considering it as a fair coin. So n is given, p is given. So E of x will be n into p, which is equal to 2 into half, which is equal to 1. So the answer is B, 1. The probability distribution of random variable x is given by this table. For x equals 1, p of x is 1 by 8. For x equals 2, p is half. For x equals 3, p is 1 by 8, and for x equals 4, p is 1 by 4. Then the value of v of x, that is variance of x, is equal to what? So variance is given by e of x square minus e of x the whole square. Now e of x square is summation of pi xi square. So this will be equal to 1 by 8 into 1 square plus 1 by 2 into 2 square plus 1 by 8 into 3 square plus 1 by 4 into 4 square. So this adds up to 1 by 8 plus 2 plus 9 by 8 plus 4. Let this be as it is. Now e of x is summation pi xi. So this is equal to 1 into 1 by 8 plus 2 into half plus 3 into 1 by 8 plus 4 into 1 by 4, and this is equal to 5 by 2. So variance is given as 1 by 8 plus 2 plus 9 by 8 plus 4 minus 5 by 2 the whole square. So this will give us the final answer as 1 plus 16 plus 9 plus 32 minus 50 by 8, which is equal to 58 minus 50 by 8, which is equal to 8 by 8, which is 1. So the answer is B, 1. The mean and variance of heads in 3 tosses of a coin are, so we are given n is equal to 3 tosses of coin. We assuming it to be a fair coin, so P will be probability of getting a head, so this will be half, and Q is also half, that is probability of getting a tail. So we are supposed to find mean and variance. So mean is given by E of x, which is equal to n into P, which is equal to 3 into half. This is equal to 1.5. So mean is 1.5. So the answer is A, 1.5. Let's also find the variance. So variance is NPQ, that is E of x into Q. So this will be equal to 1.5 into half, which is equal to 3 by 2 into half, which is equal to 3 by 4. So this confirms the answer, which is option A, mean equals 1.5 and variance equals 3.4. The random variables takes values 1, 2, 3, 4 with probabilities 1 by 6, 1 by 3, 1 by 3 and 1 by 6 respectively. Then the mean and variance are, mean is given by E of x, which is equal to summation of pi xi. So this is equal to 1 into 1 by 6 plus 2 into 1 by 3 plus 3 into 1 by 3 plus 1 by 6 into 4. So E of x is 5 by 2. So E of x is 5 by 2. So it is either option A or B. So let's find variance. So variance is E of x square minus E of x the whole square. So E of x square is summation pi xi square minus E of x we already know. So this is 5 by 2 the whole square. So pi xi square is 1 square plus into 1 square into 1 by 6 plus 2 square into 1 by 3 plus 3 square into 1 by 3 plus 4 square into 1 by 6 minus 25 by 4. So this is equal to 11 by 12. So the answer is A, 5 by 2 and 11 by 12. The random variable x has the following probability distribution. For x equals minus 3, probability is 0.05. For x equals minus 1, probability is 0.45. For x equals 0, probability is 0.2. For x equals 1, probability is 0.25. And for x equals 3, probability is 0.05. Then the mean is, so mean is given by E of x, which is equal to summation pi xi. This is equal to minus 3 into 0.05 minus 1 into 0.45 plus 0 into 0.2 plus 1 into 0.25 plus 3 into 0.05. So this is equal to minus 0.15 minus 0.45 plus 0 plus 0.25 plus 0.15, and this is equal to minus 0.2, which is equal to A, which is option A, minus 0.2. For a random variable x, E of x is 5, V of x is 6, then E of x square is equal to what? So according to the formula, variance of x is given by E of x square minus E of x the whole square. So what we are given is V of x, which is 6, E of x what we have to find, and E of x is given as 5. So this is 5 square. So 6 equals E of x square minus 25. Taking this to our LHS, we will get E of x square is equal to 25 plus 6, which is equal to 31, which is option B. Probability distribution of discrete random variable x is given by, for x equals minus 1, P is 1 by 3. For x equals 0, P is 1 by 6. For x equals 1, P is 1 by 6. And for x equals 2, P is 1 by 3. Then the value of 6 times E of x square minus variance of x is. So first we have to find variance of x. So for before variance of x, we'll have to find E of x. So E of x will be summation pi xi, which is equal to minus 1 into 1 by 3, that is minus 1 by 3, plus 0 into 1 by 6, that is 0, plus 1 into 1 by 6, that is 1 by 6, plus 2 into 1 by 3, that is 2 by 3. So E of x is 1 by 2. Now variance is E of x square minus E of x the whole square. So first we will have to find E of x square. So E of x square is we'll substitute the values directly. So this is summation pi xi square minus E of x the whole square, that is half square. So pi xi square is minus 1 square into 1 by 3 plus 0 plus 1 square into 1 by 6 plus 2 square into 1 by 3 minus 1 by 4. So variance is equal to 19 by 12. So what we have to find is 6 times E into E of x square minus variance of x, and this is equal to 6 times E of x square is summation pi xi square. So this is minus 1 square into 1 by 3 plus 0 plus 1 square into 1 by 6 plus 2 square into 1 by 3 and minus variance, that is 19 by 12. So 6 times E of x square is 11 minus variance is 19 by 12. So this gives us 113 by 12, which is option B.